way with declaring these companion classes, these objects of a certain name, often the same name as a class. So here in the Singleton pattern, the name is a little bit misleading because sometimes we don't have just one instance, but we'll have several instances, but a defined number of instances per class. And it's particularly common for use with value objects. Because value objects, it doesn't matter if we have multiple of them or just one from the standpoint of functionality. Instead of referring to several of them, if they're the same, we can just as well refer to one. We don't have to worry that that one is going to be changed and so the others are going to be modified. It doesn't matter how many are in use because they all act the same. Right? If you have a double, it doesn't matter really, and you have several different uses of it. It doesn't really matter, so pi, right? It doesn't really matter if they're all secretly referring to the same bits, or they're referring to separate bits with separate copies of it. It doesn't really matter functionally. They're all acting the same. We don't have to worry that one of them is going to be overwritten or what have you. Okay. So singletons are a very common pattern, and they provide a single point of access for an instance of a class, single point of adaptation, and via subclassing, you can allow for refinement. We'll talk about that in a little bit. And often they're used to sort of throttle the number of objects you have. So an example might be you have a thread pool, and you go to this thread pool, and it has a certain number of threads, a certain number of instances of it, and you're waiting for a given thread to be available. But you go through it to get access to these threads, and it can put you in a queue if certain threads are not available. Okay. Okay. So we're going to come back to this issue of comparing this to static fields in a minute. So here's an example from C++. This is from the Gang of Four book by which was created by four famous authors, including Lysicides and Eric Gamma, and two others. And here we have a maze factory, and we have a static variable that's called the instance, a static method here that's called the instance, and it returns a maze factory. And this is captured by a static variable under our instance, which points off to a maze factory. So here we have this class, and there's a static variable for the class which points to a single instance of maze factory. Okay, and when we request that instance, we check if it's null, and if it's not null, we just return it. If it is null, we allocate a new maze factory. Okay. So in other words, if it needs to be filled in, we fill it in now, and otherwise we just give back, we remember the previous version and give it back. So this creates a singleton. Why a singleton? Well, we have a class, and there's one instance of the class here, and this instance is given out reliably to someone who asks for it. Notice that this is static, so this is a property of the class, not of a particular instance of the class. The class itself remembers the single instance associated with it. You've seen this many times before? This sort of thing? Okay, now, let me ask this. This is one way to accomplish it. Another way, suppose we considered a maze factory. Another way to have it would just be to put all the properties that we seek to get access to through this instance, just put them as static variables within maze factory. So we just have one copy of that variable for maze factory. Why is the singleton any better than doing that? So here, it may seem like a lot of work. After all, we have this instance, which refers to a single instance of the maze factory, and that has lots of instance fields in it, lots of particular variables in it. And we give a reference to it back whenever we need it and throb those. Why is that any better than having static variables within maze factory we directly refer to? Why have an instance at all? Why not just go through static variables of the class? Why have an instance of maze factory? Why not just do everything with static variables and methods? under that? Well, it turns out that there's several advantages. So one of them, maybe it's a little bit more obvious, is we can have multiple instances. I mean, right now, we only have one instance. This is the fine instance. Underbar instance refers to the single instance associated with maze factory. But in general, we could have an array of defined size. We could have 10 of them. We could have 12 of them. We could have a number of them that, in short, is up to our choosing. And we could go through them in a round-robin fashion. The next time someone asks, we could give out the next one. And in fact, if all of them are already out, if they haven't been released, we might block until the next one's available. The point is, here we have one instance, but we could generalize it to be 10 instances or 100 instances quite readily. Whereas if we just had static fields within Maze Factory, no instance at all, we only have a choice of 1 or 0. One or many. We don't have, if we have static, we have 1 copies of each field, not potentially 100. So that's one reason. We can have multiple instances quite readily. The second is a little bit more deeper, and that has to do with subclassing, ladies and gentlemen. Here, after all, we're allocating a new maze factory, okay? And we're using that to the instance. But in general, we might have this instance point to subclasses of maze factory. Ones that have to do with different types of mazes, different types of labyrinths, or what have you. The point is that this instance doesn't always have to point to this class. It could just point to something that's a subtype of this class. So instead of having this new maze factory hard-coded, we might allow, for example, clients to specify the particular class they want to maintain a reference to and use that instead. So the point is, this instance here we know that it refers to maze factory, but in general it could refer to a subtype. And those subtypes might be different. So in short, we have two big advantages over just putting everything in here as a static field and static method. We can have multiple instances of these things, not just one. Here we have just one, but we could have multiple, and then we can override it through subclassing. Instead of having a reference to maze factory, we could have a reference to subclasses of maze factories that do different things. Singleton pattern. You have a class, you have a static method in the class, and that static method, yes, this one here, static field as well, and that static field refers to an instance of a class that's this class or a subclass. Okay, sounds a little bit involved, but it works really well actually. You go to the class, you ask for the instance of it, and it gives you back this reference. And it could be a reference to that class itself. It could be a reference to a subclass. You don't know. But you use it quite readily. And it might give you different instances in a round-robin fashion, for example, if there's more than one instance. Does this make sense for why you might do this? So now this provides kind of the one way of accessing, the one route by which you'd access a maze factory. You go to the maze factory here. But it's a very, very common pattern. And we will see how this gets used in other cases. I would just note that this is very similar to what we see with object singleton classes within Scala. Okay. Now we're going to talk about a separate pattern that builds on this, and it illustrates this. And this is called the flyweight. And the idea here is that we have a situation where we need to store information on a massive number of particular cases. Okay, so we have perhaps a document, which could be, if you're in the legal field, maybe thousands of pages in length. Okay, and this document has within it text, and this text, this class. Is for 7816. This text can occur in different fonts and different characters and different font sizes and in different styles, like bold, italic, etc. And if this text is thousands of pages of length, one hopes it'll be more interesting in content than this, but if it's thousands of pages of length, that's actually going to be a huge amount of data you're going to need to store. If each of these instances you have to refer to something that encodes. For each position, you have to refer to something that encodes the particular character, the font size, and the font style. It's going to actually take a lot of resources. For each and every position, you need to manually sort of go off and record these things. So, and more than that, we're going to have a lot of repetitions. So here we might have S, and we're going to have the font and the font size and the font style. And for this one, we're going to have as well S, and as it turns out, the same information, right? And the same thing for this. So we're going to have a lot of repetition where if we do it naively, we're going to have the same basic information stored in multiple places associated with different positions. Does that make sense? This is going to be quite wasteful because we're going to have different positions which differ, yes, in terms of their context, in terms of their location. And they're each going to be referring to a lot of the same data. So potentially wasteful. And the flyweight basically helps us deal with this situation. Okay, so the key virtue that we exploit here is a combination of value objects and singletons. Okay, and instead of having a massive number of totally separate objects, we have a massive number of references to a smaller set of objects. So rather than referring to separate objects here for each of these classes of S, we're going to instead have them refer to the same basic underlying object. Okay? We're going to have them refer to the same underlying object. And this object being shared, guess what sort of object it will be? That we can safely share it. We don't have to worry how many people point to it. Immutable. It's immutable. It's a value object. Okay. Value object, we could be the only person pointing to it, or to have 10,000 people. We don't have to worry that it's going to be any different. We don't care how many people refer to it because it can never be changed. Okay. So it's an immutable object. Okay, and there's only one of them for this context. There's only one. Given those contents, there's only one. There's never more than one. Okay. So here we're going to have a flyweight solution that will capture the font, the sizes, the effects, the color, etc., in an immutable flyweight, and the character and position here will be stored either implicitly by where we are in the array of contents or some other information that's maintained on sort of about these different pieces of the document. So it's stored separately from this. We don't want these objects to encode position within the document, or now they can't be shared. So these will be the basic features of the data for that position for a given case, and we'll have different positions referred to it, okay? And if we end up going and deleting one of these things, if we end up deleting, I'm not sure what to delete here. Suppose we were to change this capital IS, which was referring to something here with a really big font, and we were to change this to a lowercase is, then this guy would now refer to this. This I would refer to whatever this one did, and this thing would be cleaned up through garbage collection. It's no longer needed. This capital, this big letters that were used here, so they'd be cleaned up. we don't need them anymore. Nothing refers to them, and therefore they can be deallocated. Okay. So while this may have a huge number of different positions in the document, we only require a modest number of flyweights associated with this. Okay. And if you change the size, the font, etc., you're not going to be updating the current flyweight. You're not going to be updating one of these. These are immutable. Instead, you'll be simply moving your reference to another one, if needed, allocating another one, and potentially the one that you referred to before will be garbage collected if nothing's needed. Okay? So here we make use of a modest number of flyweights. So we'll have something like this, right? Bob did not. Here we have these in different colors. So, for example, the O here is different from the O here, but we'll have reuse. So if we have Bob in blue, you know, this this given underlying object will be referred to from this position and that position. We can't reuse this O because these two differ in color, but generally speaking, there's going to be a comparatively small number of different particular font types like italics versus straight and with color, etc. There's still going to be a fairly small number within the document compared to the total number of positions. Okay. Okay. So flyweight pattern. I said it combines value objects, these immutable objects, and shared references to them with singleton, because there's only a single instance or zero instances of a given one of these. Never is there more than one with the same contents. We always will reuse a designated one for a given combination of letter or content, content element character, and font characteristics, including color. We'll always just reuse that. So this combines singleton and value object in a useful way. This sort of flyweight pattern is a very scalable pattern that you will see in quite a few systems in order to deal with this case where we have large numbers of needs for a comparatively small universe of possibilities. Does that make sense? People comfortable with flyweight? And see how it builds into, it draws on singleton and value object? Okay. Okay, so ladies and gentlemen, the next thing I'll talk about, and I'm trying to think about what will fit into this next little bit. I may just go on to talk about here layering. So some of the patterns we'll be talking about are patterns that involve design elements like this, where we're kind of using these features, the value objects and singletons in a convenient way. Sort of low-level structures, and others are more architectural. They're more patterns we use when building an entire system. And one of the examples of those has to do with layering and abstraction. I should probably stop this.